In this video, what I'd like to talk about is PHP's ability to be able to handle strings. Strings, of course, are a very common data type in PHP that we've spent a lot of time working with. We've seen them throughout most of the examples we've been experimenting with. Strings in PHP, of course, are series of characters that are surrounded either by single or double quotes, single or double depending on whether we want to allow string interpolation to happen or not. Besides PHP's basic ability to support the string data type, PHP, however, has built into it a great many different functions whose basic purpose is to give us some extra capabilities when it comes to strings. If you take a look at PHP's website, if you go to the search box up in the upper right-hand corner and you actually search for strings, PHP will bring you to a special page in their documentation that discusses just that subject, just the subject of how strings can be worked with in PHP. What I wanted to point out to you here is that PHP contains a great many different string functions. There are a lot of them, and what I'd like to do in this video is go through each one of them one at a time in the most boring fashion possible. Now, I'm joking, of course. I don't actually want to make any attempt to go through all of these different string functions, hopefully letting you know that they're here in the documentation where you can find them and read about them is going to be enough. But I would like to go in and take a look at a few of my favorite string functions, some of the string functions that I use more commonly than most of the others. To talk about some of these different string functions, I'm actually going to come back to our colors example again. I know you're probably thinking, oh no, colors, didn't we just spend like 4 hours of video time talking about this example? But I thought it might actually be a little more interesting and a little bit more practical to look at some of our string handling functions here within the context of a more realistic example, rather than writing little silly examples that just demonstrate the functions themselves. What I'd actually like to start doing here on my index page for my colors example is not actually talking about colors, but let me begin by actually showing you a different way that we can get the data out of the file. The way I've been doing it in all the examples up to this point have been by using the fopen function. As far as you know, as far as I've mentioned in these videos up to this point, that is the way to be able to open and read from a file. What I haven't mentioned to you, though, is that there are actually some other possibilities. One of those other possibilities is a function I like very much that's simply called file. The way this file function works is you simply provide it with a file name, and what that file function then will automatically do is locate that file, read all the data from it, and return that data to you as an array. The file function only handles reading data. You don't use it to write. Anytime you need to write data, you're still going to need to use fopen and something like the fwrite statement. But since very often what we need to do is simply be able to read from a file, this function can be very, very handy. What this function does for us is it reads in the entire content of the file and returns each line of that file as a separate element of an array. So if my colors file has 14 lines in it, what I will get back is a 14-element array, each element of that array being one of the lines from my file. So it does a little bit of the parsing work for us, but where the file function doesn't help is that each of those lines that's returned is still just a solid string. It's not broken up into individual fields like we were actually getting with fgetcsv. That's where our string handling in this video will actually start to come in. But as far as the file function itself goes, I do like it a lot. Part of the reason I really like it is that it takes the place of the fopen, it takes the place of the checking to see if the file was opened, and it takes away the need for us to have to close the file again. All of that is basically handled automatically. What happens if the file function can't find the file that's supposed to be opened? Well, then it just doesn't find it. What it does is it returns an empty array, an array with nothing in it. So instead of us having to check to see if the file was found, or if the file connection to the file was properly opened, we can simply check to see if our array is empty when we're done. So this one function by itself will give me back a list of all of the lines in the file, an array, I guess I should say, of all of the lines in the file. From that point, it's still up to me now to go and process them. Since lines should be an array, I can work my way through that array very easily using a for each loop. Here we are. In my for each loop, let me tell it that I want to go through each of my individual lines. I'll take each of those lines as a variable called record. So each iteration through this loop, record will be a separate line from the file. And what I really need to do at that point then is I need to be able to take that record, that line from the file, and I need to be able to split it up based on a tab, essentially the same way that fgetcsv was doing for me before. This is where the first of our string functions come in. There's a string function that I like a lot called explode. The way the explode function works is you provide it with a delimiter. For example, I could tell it a tab, and then you give it a string that you want to have exploded, like my record variable, for example. What the explode function essentially is like a split function that you would see in most other languages. The explode function will take the string that you've provided and the delimiter, and it will split that string up based on that delimiter. So if this record string contains 5 different fields, each one separated by a tab, then the explode function will end up giving me back an array of 5 separate fields. I could take that array and store it here in a variable. Once I have that line exploded, at that point I'm very much back in a position like I was here inside this while loop the way I was doing this previously. What I could do now is I could essentially do the same conversion from a numeric array into an associative array that I was doing previously. I'll just move that code from my old while loop up here to my for each loop, and I'll go back and I'll clean up the rest of that while loop that's left over when I'm done. So I've converted the code from one way of being able to read data from the file here to a new way. Can't really specifically say that one way is necessarily better than the other. It's really very much a preference, but I think that this way just looks a lot cleaner. The control structures themselves aren't nested nearly as deeply. We don't have ifs inside whiles and that sort of thing. Really, the only control structure I have doing it this way at all is this big for each loop that goes through all the lines read from the file. I appreciate the simplicity of the file function itself in that I don't have to open with a mode. It's automatically read when you use file. I don't have to worry about remembering to close the file again. I think the whole thing is just a little bit easier. But of course this wouldn't at all be possible if we didn't have this explode function. If we didn't have the explode function to parse our input lines for us based on the tab like we were doing previously with fgetcsv, then this file function wouldn't be a whole lot of use to me, not in this particular kind of situation anyway. Let me go ahead and jump back over to the browser now and let's take a look and see if everything still works. Here in the browser, if I go ahead and hit refresh, it doesn't look like much of anything has actually changed. So we're accomplishing virtually the exact same thing we were before, just in a slightly different style. Now, here in the actual output that's being generated and given to the browser, I want to take a look at the code that's being created. Here in this code that's actually being generated, I can scroll down to the body where my table is, and down here in the body where the table is, you might notice something that's not necessarily a problem, maybe just something that you might notice. Essentially, you notice all these little bits and pieces that are stuck over here on the right. This little semicolon quote greater than, that's supposed to actually be here at the end of this color. And this closing anchor tag, that's supposed to be here at the end of this color code. If we look through here, what you'll notice is that each one of these color codes actually seems to have a new line that's falling in there behind it. That's not actually making any difference at all in the way it's rendered in the browser because of course the browser is basically ignoring that extra white space. It does make the generated code a little bit uglier, but that's not exactly the end of the world. But having that extra new line falling in at the end of every color could potentially cause us some other issues further down the line. If we were, for example, reading the data on our update or our delete pages, and we had an extra new line in our data that we weren't expecting, then when we took that data and wrote it back out to the file again, that could be a catastrophe. Instead of lines only having one new line at the end, we could end up with multiple new lines, which would result in blanks in our data file, which would basically mean that we'd have blank colors in a big corrupted file. Not something at all that we want. So we have to be on the lookout for extra little things like that, extra new lines, extra white space that might not be desirable. In this particular case, the reason that that new line is actually in there has to do with the change that I made switching over to the file function. When I switched over to the file function to read my data from the file, that also then required that I switch over to the explode function. Between the two of those, what actually ends up happening is that the new line character that's at the end of each one of my colors, essentially the new line after the blue value at the end of each line in my data file, is not actually being stripped out. The new line was being stripped out for me previously in an automatic way by fgetCSV. Here, technically, I would say it kind of should be stripped out by the file function, since it is recognizing those new lines and using it as a delimiter to split my file up into individual lines, but whether it's supposed to or not, it simply doesn't happen. The file function does not remove those new line characters. When we then come down and we actually split our line using explode, whenever the blue value is separated from all the other values and put into the fields array, the blue value at the end there actually still has that new line attached to it. So when I come down and I actually have my field 4, which is the blue value, that's of course the 2-letter code or 2-number code blue value plus a new line that's then getting put here into my color array. That then becomes part of the data that I'm actually writing out to the body of my page. If I wanted to be able to get rid of that new line, which I certainly do, PHP provides quite a number of different string functions that help us with whitespace problems, getting rid of various white spaces that we might not want in different places. For example, there's a function called ltrim, L-T-R-I-M, which removes white space off the left side of a string. There's also a function called rtrim, R-T-R-I-M, which removes spaces off the right end of a string. In this particular case, the white space that I want to get rid of is on the right end of the string. But there's another function that I usually use anyway, just called trim. The trim function itself just gets rid of all leading or trailing white space. So any white space at the beginning or any white space at the end will be removed. I could go ahead and remove it here from field 4, but what I think I would actually rather do is I'm going to come back up and actually remove that white space from record with the trim function. I'm going to remove it from the record variable because in the future, if I ever add other data to my file and maybe blue is no longer the last piece of data, then it will keep me from having to remember to come back and move where I'm trimming that white space from. I just always want to trim the white space off the end of the line is essentially what that will come down to. Let's take another look in the browser and see if that hidden new line seems to be gone now. Here in the browser, if I hit refresh now, scrolling back down to the actual data table, you can see there doesn't appear to now be any extra white space after those color codes, after those blue values. Nothing's getting bumped down to the next line and falling over to the left margin. So that seems to have fixed that one little problem. In PHP, it's always a good idea to be on the lookout for extra white space. It can be tricky because, of course, we can't see it. So you have to look for the signs that it's actually around. Alright, in playing with this new way for us to be able to read data from our file, we've seen the explode function, and I think the explode function could actually help us out in another place here inside our project as well. Here in the browser then, let me go over and take a look at the new page. You might remember that for sort of efficiency's sake, we put some loops into the new page to make it a little bit easier for us to set up our different fields in our form. We put it in as a loop because it helped with our validation. It kept us from having to repeat an ugly little bit of code 4 times. Instead, we could just have it there inside a loop. But one of the results of that was that we ended up with these ugly field names. We had the same basic problem also happening in the validation itself with these ugly field names. I don't guess you could really say that the field names are ugly. What they are is they are basically technical. What we're doing is we're taking the actual HTML names of the 4 fields that are in our page, and we're using those to actually display them to the user, which is not exactly the best user experience. Back over here on the new page's code itself, what we had done was we had created this array called field names, and in that array I have the actual HTML names of all 4 of those different fields. In order to actually create the form then, the form itself started basically like normal. Then I had this for each loop where I went through each one of those field names. For each one of those different field names, we checked to see if there was an error for it. If it was, we put it in an error field class paragraph. If there was no error for it, we put it in a regular paragraph. And then in the label itself, we say that that is the text that the user is actually going to see right here. We also then down in the input field itself use that name in various different places, but most of those places are pretty invisible, so those aren't really causing us much of a problem. Up in the validation for this page, we're doing essentially the same sort of trick. With those field names and a little for each loop, I was able to do all the validation for all 4 fields just here in just a couple of lines of code. What I had done here with the validation is I'd said for each one of those field names, check to see if a variable of the same name is empty, and if it is, create an error in the errors array for that particular variable. So here, the name is again being used in some information that's being displayed to the user, which makes it not look all that nice. This is the kind of place where that explode function could also again potentially come in handy for us. What we could actually do here is that we would be able to actually take those different field names with the underscores in them, and we could use the explode function to essentially remove that underscore. There's other ways that we could do it, doing a more technical sort of remove, but I think explode is a pretty nice way to go. We could explode it, that would remove the underscore itself, and then we could take the two words that result and we could sort of splice them back together again. So back over in my code, if I come back down to the page itself, to the actual form, let's see if we could use explode to maybe get rid of those underscores in the field names. As I go through my for each loop here, for each one of the individual fields, I end up with that field's name in a variable called name. I'm going to put in a set of PHP tags here, and let me create a new variable called name parts. And to get the name parts, I'm going to explode the name on an underscore character. So basically take the name with that underscore in it, explode it, so that should essentially then become a two-element array. Now what I actually want is not a two-element array, but I want to put those two parts back together again. There's a function that's the opposite of explode that we can do that, use to do that with. Of course, if you're going to make a function that's the opposite of explode, what would you call it? The answer has to be implode, of course. So the implode function will take an array and will combine the parts of that array back together into a single string. So I'm going to use the implode function here to create a new variable called nicename. That will sort of be my human presentable name, essentially. And what I want to do with it is I want to combine the parts of name parts back together simply by putting a space between them. So a space becomes my join character, and name parts is the different things that I'm actually using to reassemble into that string. So explode and implode are essentially sort of opposites of one another. Explode takes a string and turns it into an array. Implode takes an array and turns it back into a string again. With nicename then generated, let's give it a try and put that in for the label that the user will see. There we are. I'll drop in nicename and let's take a look in the browser and see if that does the trick. Here in the browser, if I refresh, there we are. My actual field name's now down here, the underscore is gone, and instead we just have a space there, which has cleaned them up and made them look quite a bit nicer. I could do that essentially the same trick up there when I'm doing my validation, but before I do that, let's look at one other little bit that might make that look nicer, and that would be maybe a little bit of capitalization. Capitalization wasn't really something I wanted in my field names itself, but for presenting to the user, capitalization might be nice. PHP again has some string functions that can help us with things like capitalization. There is a function called string to upper, that's strto upper, and a string to lower function to go along with it that will turn strings into all uppercase or all lowercase. That's usually a little bit extreme. What I might actually like to do here instead is something a little bit more subtle. There's some functions in PHP called UC_first. That's just the letters UC and the word first. And another function called UC_words. UC_first simply capitalizes the first letter in a string, and UC_words capitalizes every word in a string. I think that's the one that I would want to use here. So what I'm going to do is I'm going to go back up here where I'm generating my nicename. And when I generate my nicename, I'm going to have it capitalize all the different parts of that nicename just after I've imploded it. There I've simply taken the string that's returned to me by implode, and I've passed it to UC_words to have each one of the individual words in that string capitalized. So that then becomes my nicename. Back in the browser now, when I refresh, now all of my field labels down there are getting capitalized, and they essentially look very much like they did back when I had them typed in by hand. So we're kind of back to where we were, only now we're doing it with greater efficiency because of the loop that we incorporated in. We've overcome the deficiencies that we had caused to occur because of our loop, and we're back to having a nice user-friendly looking field names now. Let's go and do the exact same thing up there for the validation. What I'm going to do for the validation is I'm just going to take the generation of the nicename that I've done here down in the field. I'm going to go ahead and copy it, and then with my validation I'm going to go drop it back in. Here's my validation. Let me drop that back in. We're already in a set of PHP tags here, so I don't need extra PHP tags. There we are. And here in the error message itself, where the user is actually going to see the name of the field, I'm going to make that the nice name. There. Let's take a look in the browser and see how it works. I'll hit refresh. And there we go. Now in the error messages themselves, they're getting those much nicer looking names. I'm not sure if we want the capitals there. For some reason the capitalization there throws me off a bit, but we could go ahead and remove the UC words at that point easily enough if we wanted to. But overall, I think that's a much better look for the way that this page is going. Eventually, at some point, we would want to go and make those exact same changes over on our edit page, since it's going to suffer from essentially the same problems we had here. One other place that we might want to potentially consider capitalization and some issues surrounding it is when we actually go and we write our data out to our output file. Essentially at this point in the new page, and probably in a place or two over in the update page as well. The reason we might want to think about capitalization here would have to do with how we're actually writing the data to the file. The way things work right now is the data essentially gets written out to the file in whatever way the user first entered it. If the user enters mixed case, some upper, some lower, then that's what we write to the file. If the user puts in all lower or all upper, then that's what we write to the file. So at the moment, the data that we're actually writing to our file essentially has no standardization to it whatsoever. In some cases, I would say not only is that okay, but it's probably necessary. For example, in the name of our color. We could take the name of the color that the user enters and we could force it to uppercase or lowercase so that we always knew exactly what we had stored in our file. But then we would always have to probably display it in that way, display it in all uppercase or all lowercase. If we wanted to make it look a little bit nicer, we could apply some capitalization using the UC first or UC words functions, but there's still going to be some rather complex situations that we're not going to be able to capitalize properly. For example, if somebody were to put in a color like Tempe Gold, if we were to convert that to all uppercase or all lowercase and then just do a UC words on it, we could display it exactly the same way. So we could have sort of a standard way of having the name stored in the file. But what if somebody put in a color and they called it TCC Gold, for example, or TCC Blue, I guess would be more appropriate? There would not really be any way for us to be able to detect that TCC was an abbreviation and that we should capitalize all three letters of it instead of just the first. So in the case of something a little bit sort of free form, like the name of a color, I would be much more inclined to simply not mess with it, because the chances of us being able to get it back to a nice displayable fashion again is pretty small. The actual color codes themselves, on the other hand, are a very different story. With these hexadecimal color codes that we've been working with separated into the red, green, and blue values, they're equally correct if they're typed in all uppercase or typed in all lowercase. So in the case of those, we could take them and store them in the file as all uppercase or as all lowercase, and then we could simply make the decision about how we want them to be displayed on the site. Do we want to display them as upper or display them as lower? Right now, you see I have a mix. Blue Jay White, for example, the alphabetic components of that hexadecimal code are uppercase, whereas down here with yellow and orange, I have the alphabetic components as lowercase. It might be nice to standardize and have it be one way or the other. What advantages would there actually be to standardizing those color codes, having them stored as all upper or all lowercase in our data file? Well, imagine that we start going through the process of building a search feature into our colors page. And maybe what we want to do is we want to allow people to search by color component. Maybe I wanted people to be able to search for colors that had FF for their red value, for example, to find colors that had a lot of red in them. Well, if I'm allowing mixed case, right, or I'm not standardizing on a case when it comes to those color codes, then when I do that search, I would have to convert uppercase, lowercase at that point, or I would have to search for the upper equivalent, the lower equivalent, or the first upper, second lower, second upper, first lower. I would have to search for all the different combinations. It would just be faster, it would be easier, it would be more efficient if I already knew what format that data was in. Actually getting that data stored in a consistent manner would be fairly easy to do. All I need to do is make sure that whenever I create a new color or whenever I update a color, essentially anytime I'm accepting input from the user, I want to make sure that I take that input from the user and that I convert it to the form that I want it to be in before I actually write it out to the file. So what I could potentially do here on the new page when I'm writing a color out to the file is I could go through and I could just convert each of those color components, red, green, and blue, I'm going to say to lowercase. So for each one of them, I'm going to call the str to lower function. There it is for green, and there for blue. And that way, whenever I take those three values that were given to me by the user, filled into the form, I'll convert them to lowercase before I actually write them to the file. Let's take a look and see how that works. Back over in the browser, I'm going to go to my new page. Here on my new page, just to double check, validation's still working just fine. Let me try creating a new color. I'm going to call it gray, and I'm going to give it the value of capital C's. There we are. So I put in all capital C's. I'm going to go ahead and save that color. There's my new color that was created. I can see right here, those C's are now showing up as lowercase. When that data got written out to the file, the C's were all converted to lowercase. And then when we got redirected over to the show page and the color was read back in, since the show page doesn't say anything about how to format them, it showed them in exactly the same format that they came from the file in, lowercase. If I go back over to my index page and take a look, they're all lowercase there. Even though I entered all those letters as uppercase, they got converted to lowercase whenever I saved them. I could make essentially the same change over on my update page as well, and one of the interesting things about that is since the update page rewrites my entire file, that would actually go back and convert all these other colors that already have uppercase letters in them to lowercase as well. I could also now at this point go ahead and decide on how I want to have these things displayed. If I want to have the colors all displayed, the color codes all displayed in uppercase, maybe here on the index page, I could do that easily enough. In the code for the index page itself, down in the actual body, when I'm looping through all of my different colors and putting together the table rows for them, I generate this code variable, which contains the red, green, and blue values that are used to put that value together. If I go ahead and take that and I convert that to all uppercase, then that code will be in all uppercase, and that's what will actually get written out to the page. There we are. So at that point, I essentially am storing all of my color data in my file as lowercase, and I'm displaying it here on my index page as all uppercase. So I've got good consistency. Good consistency for what the user is seeing, good consistency in my data so that I'll be able to search it and work with it more easily again in the future. So as you can see, PHP has a great many different functions that are useful when dealing with strings, and dealing with strings is certainly something that you'll do quite a bit of in PHP. Pretty much all the input we get from a form starts its life off as an actual string, maybe to be converted to some kind of number later, but certainly a string at the beginning. We do a lot of work with strings when we're actually displaying information for the user. Strings are just sort of all over the place. My general recommendation would be some boring Friday night when you don't have anything else to do, spend a little bit of time flipping through that list on PHP's website of the different string functions that are available. You don't necessarily have to go through and memorize them all or practice with them. Just make yourself sort of roughly aware of what's available and what isn't. And in the future, if you ever find yourself struggling with any kind of string problem, you find yourself trying to create some fancy solution to deal with some issue dealing with a string, before you get too far into it, make sure you go back and make sure that PHP doesn't already have some way of being able to deal with that particular aspect of a string. There's a pretty good chance that it's already there.